I mean, the credo of saying like simple things work and complicated things don't is, I think, quite true here as well. Like, of course, if we start, or like when we started to improve the method of in-situ NMR being applied to various type of energy storage materials, we thought about this one probe that can solve a lot of questions, right? That can help us to gain insights into various type of materials using all the nuclei that are out there in various magnetic fields. When it comes to applications in the industrial sector, I think that the question they have there is much simpler. They want to know, like, is my material fine or is it not? And, we are focusing on this type of material with this type of nuclei. How can NMR help us here? And for exactly these questions, we are more or less already capable of providing equipment, namely an NMR probe combined with a certain set of cells where people can put in their materials. A standard that people use actually to test their battery materials or their batteries is a so-called coin cell. So that's a little stainless steel thing that you put more or less anywhere. And this is also done in the lab scale, just to, assemble everything, and then you put it in a cycler, and then you see the electrochemical performance of your material. And we already do have a probe, actually, that can hold and handle one of these stainless steel cells that you just insert to the probe. Then you insert this probe to your magnet, and you press basically go for the experiment, and then you run your in-situ NMR experiment while you also run the electrochemical and the NMR experiment at the same time, which is in-situ NMR. And so this probe combined with the coin cell is surely something that simplifies the work people have to do a lot, because they can actually use the device that they already took out of their production line to test into their probe. It's the same with pouches, for example. A lot of applications in the sector are used as pouches, like aluminum covered pouch cells or something like that are then rolled up or put together into bigger battery packs. And with the challenge that we did overcome to measure through actually these stainless steel coin cells also helps us to measure directly into these pouches made out of aluminum foil or something like that. It's not only aluminum foil, it's more elaborated, but in a simplified way. And so this is surely one way to improve that. And if we then combine this with software tools that allow the user afterwards to use the raw data from the electrochemistry experiment as well as from the NMR experiment, and just basically load these two data sets and get very quickly a graphical, analysis and which shows you the electrochemistry data as well as the in-situ data with all the signals that are out there. This is something we already have, and we can tweak that for a particular user if they want to do some, line analysis, peak fitting, or something like that. So I'm pretty sure that we can, or we are working on that actively, actually, but we will. I'm sure that we can also provide that in the near future, so that people have this more or less plug and play technology when it comes to the in-situ part for a particular research question. And I think this is really what people will consider to be more, useful maybe for their, R&D facilities or whatever.